direct variation. And this says y varies directly as x, or y is directly proportional to x. That's two different ways of saying it. So what they're saying is there exists a value k called a constant of variation such that this is the equation. So whenever you have something that says y varies directly with x, that means y equals some constant k times x. Okay? Now, to illustrate exactly what's going on is if x increases, so as x gets bigger, so does y. So they grow at the same portion. They go together. Okay? Or they grow smaller together. Okay. So as one goes up, the other one goes up. As one goes down, the other one goes down. Right? So it's a one-to-one relationship. You can tell the other one's going to go down by that format. So to figure out how much, that's where this k comes into play. Right? So whenever you have something called a direct variation, this is going to be our equation to use. The other type is called inverse variation. So this means y varies inversely with x, or another way of saying it is y is inversely proportional to x. So same situation, there exists a number of k such that, however, now we divide by x instead of multiplying by x. And that's what you buy is the inverse of it, so when it comes to it. Now this actually is the opposite of everything over here, and it's probably your bank account when it comes to Christmas time, or any kind of holiday. So as x goes up, y goes down when it comes to it's just inverse proportional. So kind of like this. So x increases, y goes down, right, when it comes to it. Or the other way is just doing, let's go to, so what's this way? This way. There we go. So as x goes down, y increases, right? So it's one or the other. Okay. So, well, like I said, when it came to the bank account, right? Like, you know, how much money you have in your bank account decreases as the number of presents you buy, right? So it's an inverse relationship, right? When it comes to it. I'm sure, you know, and an example of this is like, you know, the more hours you work, the more money you're gonna make, right? So it's a proportion. As one goes up, the other one goes up. Right? So things like that. All right. So again, these are the two situations we're gonna have. So inverse means we're gonna use this equation. Direct, we're gonna be using that equation. And the last scenario is, well, what if you have a combination of a couple things? Okay. Well, what if y varies like with other stuff, not just one single variable, but two variables? So if y varies jointly with x, so it's a combination of two or more variables. In our case, we're usually going to have it in this format. It's just going to be y equals k times both of the variables put together. Okay, so when you multiply. Okay. And you'll see how this situation is going to come into play in a little bit. Okay. All right, so pretty much the rest of this section is lots and lots of examples so you can illustrate. And I think the last three examples are actually word problems. The first couple are just being able to understand the verbiage and the equation when it comes into play. Okay. So let's just try the first one so you can see how this is going to go. So if y varies directly with x, so automatically tells me, right, y varies directly. So it's going to be this one, or this one, and just varies directly. So therefore, without even finishing the question, reading it, right, we already know what equation we're going to be using. So we're going to be using y equals k times x. So right off the bat, okay, just knowing that simple fact at the beginning. Okay. All right, so now it says y varies directly with x, and y equals 9 when x equals 30. Find y when x is equal to 40. Okay. So how these problems are going to go about is they're going to give you a first situation, and we're going to find the second situation. Okay? So the first situation is x equals 30, y equals 9. Right? That's the first situation given to us. The second situation is what we're looking to find is when x is 40, what is y going to be? So you may think, oh, we'll just plug it in and solve for it. But the problem is we don't know what this constant k is. What's the growth of it, right? So how much is it growing? So before we actually solve for this situation, we must first solve for k and then write this information out. So we're going to use our first situation to solve for k. So just plug in where they're supposed to be and just solve for k. So it's just simply just dividing this over. So we know k is going to equal to 9 over 30. Okay. So now that we know this, now we can go to the second situation and solve for y. Okay. So we know it's going to be y equals the k, which we found is 9 over 30 times 40. And now we just multiply and divide, right? So 9 times 40, again, just using a calculator, and then dividing by 30 gives us a nice 12. And there we go. That's all we have to do. So again, just got to remember, you must always find k first and then go to your second situation. So any questions on our first example here? Everybody good? Okay. Let's go on to the next one. So it says if m varies jointly, okay, here we go. We got jointly. So we have it up here, jointly. So we know it's going to be y equals k x z. But notice they have different letters, which is fine. No big deal, right, when it comes to it. If m varies jointly as z and p, oh, so we have a couple of them. If m is 10, so let's just rewrite what we have. So it's going to be, instead of y, it's going to have m equals k times z times p. So that's going to be our equation because, again, these are the letters they chose for this example, right? So I'm just going to associate those letters to the equation we have above. All right, so let's write down our first situation they give us is if m is 10, z is 2, and p is 7.5. The second situation is what we're going to be solving for is we want to find m, so we're looking for m when z is 6 and p is 9. So again, we're going to use our first situation to find k and then find our second situation that we're looking for. Okay. So we're just going to plug in these three letters, what they're supposed to be. So 10 equals k times 2 times 7.5, and we just solve for k. So let's see what we get. What's that? I think it's going to be 15, right? 2 times 7.5, yeah, 15. K divided over, so we know k is equal to 10 over 15. So far, so good? Okay. And now we use this one, so we're looking for m. So m equals 10 over 15 times 6 times 9. So again, just last time, multiply and divide. So 10 times 6 times 9 divided by 15. So m is going to equal 36. And there we go. Any questions there at all? No? Everybody comfortable? Okay. All right. Looks like everybody got that good. All right. This is the last one before we do some word problems, because the word problems might be a little bit more difficult. So it says y varies inversely as x. So let's going to be the last equation we had to deal with. So we know y equals k over x because that's inversely. Okay. All right, so let's write down our first situation we have. So first situation is y equals 20 when x is 1/4. All right. Now, if you want, we'll convert this to decimal if it's easier. That's the same thing as 0.25. Okay, second situation is find y, so we're looking for y, when x is equal to 15. Right, so again, same thing. We're going to find k first, so it's going to be 20 equals k over 0.25. So in this case, instead of dividing, we're not going to be multiplying, right? So I'll let you guys finish. What is k going to be? And what is y going to be? So there you go. Go for it. I'll give you guys a minute or two to find what k is, and then finish the problem. What's y going to be? All right, so everybody that wants to try. Okay. Right, so it looks like everybody got them right. Yep. So multiplying, that gives you 5. Right. So therefore, second solution is going to be 5 over 15, which is just 1/3, or 0.33 if you like the decimal. So before we go any further to the actual word problems, any questions on our just basic scenarios itself? So everybody good, comfortable using the different types of equations when it's directly, jointly, and then inversely. So notice, right, we're just plugging in the equations where they're supposed to be. So each one has its own specific equation to deal with. Okay. So now let's see how this is applied in real life scenarios. Okay. All right. So let's suppose we have the pressure exerted by a certain liquid at a given point varies directly. All right. So we know that should pop up as the depth of the point breadth of the surface of the liquid. The pressure at 10 feet is 50 pounds per square inch. What is the pressure at 15 feet? Okay, so a lot of stuff happening, right? But we know varies directly. And varies directly means it's going to be this equation here, right? Y equals k times x. We'll just write that down for now. So I don't know what they're talking about, but I know we're going to be using this equation somehow. Okay. Okay. Next up, we want to identify a couple things. Okay. So notice before the varies directly is always the value of y, right? Y, right, portion. So let's see what they're talking about here. So the pressure exerted by a given portion. All right, so looks like the y value is going to be the pressure they're talking about in this little scenario. Some whatever pressure they're dealing with, some liquid, right? So therefore, the x variable is the stuff afterwards, and it says the depth of some point, right? So depth, I'll just write that down. So depth of liquid, I'll just put that. Okay. All right, so now that we have kind of what's going on, let's actually write down our first scenario. So what's actually given to us to be first, to meet our requirements to it. So it says the pressure at 10 feet is 50 pounds per square inch. Okay. Well, let's see. So we got to figure out what the heck is x and what is y in this case, right? Because we're giving us two different things. Well, I know 10 feet is a depth, right? So depth is like, you're measuring how low it is. So I know this has to be 10 because that's the depth. So therefore, by default, right, that means this has to be the pressure. So 50 is the PSI stuff they're talking about there. Okay. So looks like we got our first situation here. So now let's write down our second situation. All right, so second situation, this says, what's the pressure? All right, so we're looking for pressure, and I stated that was y, so we're looking for y at 15 feet. So, and we said that's depth, so x is 15. Okay. So again, very similar to what we have here, but now it's in word problem format. Okay. So again, before I go any further, or any questions on how just we set up the problem at all? No? Everybody comfortable? Okay, all right. So in that case, we do the same thing we did for the first one. So using the first scenario, we're going to have 50 equals k times 10 to solve for k. So divide it over. So this k is going to equal 5 in this case. And now we can find our last example. So y equals 15 times 5. And that's going to be 75. So the pressure is 75. I guess PSI, but that's perfectly fine there. So everybody comfortable with the first example? Good, good, good. Okay. All right, so in that case, let's try the next one. So it's a little bit more complicated, right? So we just got to read it slowly. So it says the illumination produced by light sources varies inversely. All right. Varies inversely. So we know that's going to be our equation, right? And varies inversely. So the last scenario we had here. Okay, cool. So we got that going. So varies inversely as the square of the distance from the source. Okay. The illumination of light source at 5 meters is 70 candelas. What is the illumination 12 meters from the source? Okay, so I don't even know what they're talking about here, but somehow we got to figure out our x and y, right? So again, I figure out x and y stuff. Okay. So same thing, varies inversely. So therefore, all this stuff is going to be the y insulation. So the illumination produced by light. So it's just the illumination, I guess I'll call it, is going to be the y, and therefore the distance, or in this case, the square distance, is going to be the x. All right, so now we have that going on. Again, let's just write down our first situation happening. Okay, so X and Y here. So it says the illumination of light source at 5 meters. So remember that's meters, so meters is distance, so we know that's going to be 5 there. Is 70, I don't know what that is, but that's, I guess, the illumination we're talking about, right, when it comes to it. So that's our first scenario. So now for our second scenario, it says, what is the illumination? All right, perfect. So we're looking for Y. 12 meters from the source, so that's the distance, so 12 meters there. So again, we go any further. Any questions on the setup of the problem so far? Is everybody comfortable? Okay. All right. So the reason I said this was a little more trickier is because when we set up this problem, we're going to have 70 equals K over 5, right? Not exactly. Because it says the square of the distance. So that means I'm squaring the distance. So that means this is going to be 5 squared there. Everybody comfortable about what I just did? Okay. So that's going to be 70 is equal to K over 25 now. And now we solve for K. So it's going to be a big number. So 1750. And now we solve for the initial one, right? So Y. So if what's Y equals, we have 1750 over 12, again, squared. So 1750 divided by 12 squared, I think it's 144. So our illumination is going to be 12 point, let's say 15, I don't know, candles. That's what they call it. There you go. All right, so everybody comfortable with the first example? Second example. Okay. All right, so if you guys are wondering, I put this as like, so kind of like easy, medium, and then difficult down here, okay? Okay, so this is the most difficult of the three so far. It says the force of the wind blowing on a vertical surface varies jointly, all right? So it's going to be a combination of the top, as the area of the surface and the square of the velocity. So jointly means this, right, from the first one. So we knew that could be. All right. If a wind of 40 miles per hour exerts a force of 50 pounds on a surface of 1/2 feet squared, how much force will a wind of 80 miles per hour place on a surface of 2 feet squared? All right, what in the world's happening here, right? Okay, so let's write some stuff down. So we need Y, X, and Z. Okay. So we know it's jointly, so that means everything before it's going to be the X. So the force of the wind blowing, so we know F is going to be the force they're talking about here. Okay. X is the area of the square, area of the surface, so area of surface. Okay. And the square of the velocity. So square of velocity. Okay. All right. So now that we have that situation, now let's actually write our first one down. What are we given? Right? So we have Y, X, and Z. Okay. So Y is force. So if a wind of 40 miles per hour exerts a force of 50 pounds, right? So force is 50 pounds, right? Just from the force. This force right here. On the surface of 1/2 feet, so what do we say surface? X is surface, so we know it's 1/2. All right, so therefore, that means this is going to be velocity. So velocity is in miles per hour, so okay, and we got that going. So we have this as our first situation. And for our second situation, it's what's being asked. Let's see. Okay. How much force, so we're looking for Y, will the wind of 80 miles per hour, and that's, we said that was velocity, that's 80, place on a surface that's 2 feet, so that's going to be 2 there. So again, are there any questions on the setup of this problem so far? Everybody comfortable? Okay. So if we set this up, it's going to be Y, oh, not what, 50 is equal to K times X times 40. Okay. So before any further, does anybody see something we also have to do?
Don't we have to include the square of the...
Yep. Good. So same as the last example, the square of the velocity, which means we're squaring the velocity. So in this case, we're squaring the 40 because that's what the velocity is. Now we can actually find all this stuff out. Okay. So first off, we do 40 squared. And then, divided by 2. That's going to give us 800. So it's going to be 50 equals K times 800. And then just divide it over. So K is going to equal to 5 over 80. No. Okay. All right, so now that we have that, now we can finally solve what we want, right? So it's going to be Y equals 5 over 80 times 2 times 80 squared, right? Because that's our velocity squared. All right, so let's see what we get. So it'll be 80 squared times 2 times 5 divided by 80. Okay, so it's a nice number. So what are we looking for? Our force. So our force is going to be 800. And there's our final answer.
Even though the the surface is also in square feet, we wouldn't have to do anything with that.
Oh no, because it told me it was an area. So just a fun fact, area is always in feet squared when it comes to it. Yeah.
Thank you.
Okay. So any questions on variations at all?